Welcome to Get Your FRQ On. This question comes from the 2002 exam, Form B. It is FRQ number 2, and it is calculator active. This question may be known as the polluted lake problem. In the question stem, we are given the fact that we have a polluted lake. We are given a rate function p prime of t that describes how much pollutant is either entering or leaving the lake at any given time. We are given the fact that at t equals 0, there are 50 gallons of pollutant in the lake, and that the lake is considered safe to swim in, I guess, when there's 40 or less or fewer gallons of pollutant in the lake. The first part of the question asks us to determine if the amount of pollutant is increasing at time t equals 9. Now, since this is a calculator problem, we have to evaluate p prime of 9 and determine if it's increasing or decreasing at t equals 9. So it would be increasing if p prime of 9 was positive. It would be decreasing if p prime is negative. However, given the function that we have, it's not entirely obvious whether or not p prime of 9 would be positive or negative. It is an exponential function. But it is a calculator question, so we can plug this into our calculator and use our calculator to evaluate p of 9. So the expression we'd be interested in is p prime of 9 is 1 minus 3 times e to the negative 0.2 times the square root of 9. Square root of 9 is just 3, so that's just the exponent is negative 0.6. But unless we know what that is, we should use a calculator to come up with a definitive numerical response for that. If we use our calculator to determine 1 minus 3 times e to the negative 0.6, we'll be able to look at the sign and determine whether or not the amount of pollutant is increasing or not at time t equals 9. So if we plug that into our calculator, we see that p prime of 9 is approximately negative 0.646. Since p prime of 9 is negative and it would need to be positive in order to be considered increasing at time t equals 9, we can conclude that the amount of pollution in the lake is not increasing at time t equals 9. Now, for a question like this, you may want to consider answering the question being asked. This is a yes or no question. It's not asking whether or not the amount of pollutant is increasing or decreasing. It's asking, is it increasing? So even though the answer here seems a little bit odd and maybe out of place, it may be the best way to answer the question. The question is a yes or no question, so answer it like a yes or no question. Right? P prime of 9 is less than 0, so the amount of pollutant is not increasing at t equals 9. Now, I'm not sure if they would allow you to say that it's decreasing at time t equals 9 and you'd still be awarded all the points and whatnot. But if there's any doubt, it's probably best to answer the question being asked as clearly as you can. And since this question is asking if the pollutant is increasing at time t equals 9, maybe the best way to go about phrasing your answer is to declare that either it is increasing or it is not increasing and just leave it at that. In part B of the question, we are asked for what value of t is the amount of pollutant at a minimum. Well, the amount of pollutant will be minimum either at an endpoint of the domain of this function or some value of t in the domain where p prime of t is equal to 0 and also changes sign from negative to positive. Remember, if it changes from positive to negative, it would be a maximum, and that would not be the point we're interested in. Or possibly p prime of t is undefined. Now, given the function that is equal to p prime of t, it's not going to be the case that p prime of t is undefined because the p prime function is continuous everywhere. We don't have to worry about that for this one, but just keep that in mind that in general, minimums can occur where the derivative is undefined. All right, so what we're going to want to do is we're going to want to set p prime of t equal to 0 and solve that equation for t. That will tell us when the derivative is equal to 0, and then we can apply some more analysis to determine if it changes from negative to positive or positive to negative. All right, so if we want p prime of t to equal 0, that means we want 1 minus 3e to the negative 0.2 square root of t equal to 0. So 1 would have to equal 3 times e to the negative 0.2 square root t, which means 1/3 is equal to e to the negative 0.2 square root t, which means t is 25 times the natural logarithm of 1/3 squared. Because this is a logarithm, you can use log properties to write this in a number of ways. Because it is a calculator problem, you can even type this in on your calculator to get a decimal. If you do get a decimal, and if you get the correct one anyway, the decimal equivalent for the answer here would be 30.174 days. Continuing, we have to verify that this is in fact a minimum. All we've done so far is verify that p prime of 30.174 should be 0. We do have to show that this is a minimum and not a maximum. Since this is a calculator active question, we can refer to the graph of p prime of t because we can produce that on our calculator. All right, so if we graph p prime of t on our calculator, we should be able to tell visually whether or not it changes from negative to positive or positive to negative. But if we do this and we graph p prime of t, we'll be able to tell that p prime of t is less than 0 when t is less than 30.74, and p prime of t is greater than 0 for t is greater than 30.174. And from this, we can conclude that it is in fact a minimum. P of t is at a minimum when t is equal to 30.174 days. Part C, is the lake safe when the pollutant is at a minimum? Well, we just found that the pollutant is at a minimum at 30.174 days. So really all we need to do here is determine what amount of pollutant is in the lake at this time and see if it's less than or equal to 40. All right, so in order to do this, we need to set up an integral and use our calculator to evaluate the integral because it's not going to be nice. We need to know what p of 30.174 is. That would be p of 0, whatever amount of pollutant was in the lake to begin with, plus the integral from 0 to 30.174 of our rate function, 1 minus 3e to the negative 0.2 square root 2 dt. Well, p of 0 is 50, so now I have 50 plus this integral, and even though I'm allowed to calculate this using my calculator, on an FRQ, you have to write down and show your work to the point where the reader scoring your exam can clearly tell what calculus you're asking your calculator to do, which is why it's so important to write this step. Yeah, you could do this on your calculator and not write a single thing except for an answer, but the reader needs to see what calculus you're asking your calculator to do, so this step is very critical. You must write some form of the integral correctly to communicate what it is you're actually setting up. Right, so if we do this on a calculator, we can evaluate this integral, and it turns out that p of 30.174 is 35.104. Okay, so when the pollutant is at a minimum, there is 35.104 gallons of pollutant in the lake. All right, we're given in the question stem that the lake is considered safe when the amount of pollutant is less than or equal to 40 gallons. 35.104 is certainly less than 40 gallons, so we can conclude that the lake is safe. All right, using the tangent line at t equals 0, when is the lake safe? Well, at time t equals 0, we're given in the question stem that there's 50 gallons of pollutant. We can use the formula for p prime of t to calculate the derivative at t equals 0. That turns out to be negative 2. So our tangent line approximation at t equals 0 would be y minus 50 equals negative 2 times t minus 0, which is equivalent to p of t equals negative 2t plus 50. If we want to know if the lake is safe, we just need to know when will this expression negative 2t plus 50 be less than or equal to 40. Right? It's safe when it's less than or equal to 40. Simple inequality. We solve it, we get t is less than or equal to 5. So using the tangent line approximation at t equals 0, we would conclude that the lake should be safe on or after 5 days.